Hello everyone. In this video, I'm going to explain few more preferred examples based on some degrees of vertices theorem. Okay. So let me see this question. If G is a simple graph with a degree sequence, and they provide some degree sequence, means one vertex is having degree 5, one vertex having degree 2, another vertex having degree 2, like that. Three more vertices are having degree 2, 2, 1 respectively. Then the number of edges in the complement of G bar. So they're expecting number of edges in the complement of G bar. So the working principle for solving this question is looking like this. They're expecting number of edges in G bar. Number of edges in G bar. Right? So they're expecting number of edges in G bar. But we know the relation between number of edges in G bar and number of edges in G. Number of edges in G plus number of edges in G bar must be equals to total number of edges in complete graph with n vertices. Complete graph with n vertices. Okay. So they clearly mention that degree sequence is 5 to 2, 2 to 1. Okay. Therefore, by using sum degrees vertices theorem, we can find number of edges. We can find number of edges. We know that summation I runs from 1 to n. Degree of all vertices must be equals to 2 times of number of edges. Correct? Number of edges. Which implies that sum of degrees of all vertices means here 5 plus 2 plus 2 plus 2 plus 1 is equals to 2 times of number of edges. Okay. Just sum up all these values to the left side of assignment operator. So 8 plus 5, 13 plus 1, 14. 14 by 2, that equals 7. Therefore, number of edges are 7. Okay. Now, by substituting number of edges in this formula, number of edges in graph, that is 7. And we want to find number of edges in G bar. Okay. And we know that number of edges in complete graph with n vertices. How many? Which we already covered in the last video. Number of edges in complete graph 10 vertices, it must be n into n minus 1 by 2. Okay. So which is equals to number of edges in G bar is equals to, what is the value of n? N indicates here, they clearly mention that 1, 2, 3, 4, 5, 6. 6 vertices are there. Therefore, I can substitute 6 here. 6 into 6 minus 1 by 2. Right? By bringing this value 7 to the right side, it becomes minus 7. Right? Okay. So therefore, edges in G bar, number of edges in G bar must be equals to, this value is 15 minus 7, that equals to 8. Therefore, the correct answer to this question is 8. Okay. So this question based on two principles. One is sum degrees of vertices theorem. Another one is edges in the given graph plus edges in its complement must be equals to total number of edges in the complete graph with n vertices. Okay. Right. The answer for this question is 8. Now look at next question. Let G be a simple connected graph. G be a simple connected graph with minimum number of edges. Remember, whenever we are talking about minimum number of edges, so in a simple connected graph, if we say minimum number of edges means minimum number of edges must be n minus 1. Okay. If maximum number of edges means n into n minus 1 by 2. Please remember these 2 points clearly. We already covered this point in the previous theorems. Okay. Let G be a simple connected graph with a minimum number of edges. Minimum number of edges. So minimum number of edges means immediately I can say number of edges in that graph must be equals to number of vertices minus 1. That equals to minimum number of edges. Is it clear or not? Yes. Okay. If G has n vertices with degree 1, G has n vertices with degree 1. Okay. And 2 vertices of degree 2, and 4 vertices of degree 3, and 3 vertices of degree 4. Okay. First, I want to know how many total number of vertices are there. So total number of vertices. Cardinality of E is equals to n vertices of degree 1 and 2 vertices of degree 2 plus 4 vertices of degree 3 plus 3 vertices of degree 4. So therefore, total number of vertices must be equals to n plus 9. Their total number of vertices. Okay. And by using above formula, therefore, total number of edges is equals to v minus 1, right? Suppose if I call it as equation number 1. Okay. By using equation number 1, v minus 1, v means here n plus 9 minus 1. It is from equation 1. Okay. So from equation 1, we can write like this. From equation 1, we can write like this. Okay. So, but there is a relation between number of edges and sum of degrees of all vertices, right? What is that relation? We know that sum of degrees of all vertices is equals to summation irons from 1 to n degree of all vertices must be equals to 2 times of number of edges in the graph. 2 times of number of edges in the graph. Okay. Which implies that by bringing 1 by to this side, so I'll keep it as to that side only. Some degrees of all vertices. And tell me what is some degrees of all vertices here? There are n vertices. There are n vertices of degree 1. Therefore, n vertices of degree 1 plus 2 vertices of degree 2. So 2 vertices of degree 2 plus 4 vertices of degree 3. So 4 vertices of degree 3 plus 3 vertices of degree 4. 3 vertices of degree 4. This is equal to sum of degrees of all vertices. Okay. This total part is equal to sum of degrees of all vertices. Please understand. Which is equals to 2 times of edges. 2 times of edges. 2 times of edges. But what is number of edges here? Number of edges here we already discussed, that is n plus 9 minus 1. N plus 9 minus 1 means obviously it is n plus h. N plus h. Okay. This is from this equation. From this equation, number of edges in the graph n plus h. Therefore, I can substitute n plus h here. Okay. Now they're asking what is the value of n. Now simplify it. So 2 into 4 plus 12. So that equals to 16. 16 plus 12, that is 20h. So 20h. So n plus 20h is equals to 2n plus 16. From this, n is equals to 28 minus 16, that equals to 12. Therefore, number of vertices means n is equals to n, the value of n must be equals to 12. But if they ask total number of vertices, simply substitute value of n here. Substitute value of n in this equation. We'll get total number of vertices. Okay. So what is the basic principle in this problem? Student must understand that total number of edges in a simple connected graph with the minimum number of edges means n minus 1 or v minus 1. Okay. Total number of edges in a simple connected graph with the minimum number of edges is equals to n v minus 1. Okay. But total number of vertices is equals to n vertices of degree 1 and 2 vertices of degree 2 and 4 vertices of degree 3, 3 vertices of degree 4. These are the total number of vertices. Okay. Therefore, v is equal to n plus 9. Therefore, total number of edges in the graph is equals to n plus 9 minus 1 from equation 1. Okay. After getting this one, now we can take help of some degrees of vertices theorem. Some degrees of vertices theorem says that some degrees of all vertices equal to 2 times of number of edges. So sum of degree of all vertices means n vertices of degree 1, 2 vertices of degree 2, 4 vertices of degree 3, 3 vertices of degree 4. This is some degrees of all vertices. That equal to 2 times of e. E means number of edges. Number of edges equal to n plus 9 minus means n plus 8. By solving this, you'll get n equal to 12. Right? We'll see next problem. If G is a simple connected graph, please look at this problem. If G is a simple connected graph with 10 vertices and minimum number of edges, and tell me how many number of edges are there now? First, I'll write the point. Number of edges must be equals to number of vertices minus 1. The reason is they're asking minimum number of edges. Min number of edges. Whenever they're using min number of edges, the total number of edges must be equal to total number of vertices minus 1. But how many vertices they provided? 10 vertices. Therefore, 10 minus 1, which equals to 9. Therefore, total number of edges must be equal to 9. But what did they ask the question in the problem? Then the sum of degrees of all vertices in G is equals to. Means they're asking summation I runs from 1 to n degree of all vertices. Right? Obviously, we know that this value is equal to 2 times of total number of edges. Okay. So which is equals to 2 times of total number of edges means that is 9, which equals to 18. Right? Therefore, the correct answer for this question is 18. Okay. Now look at next question. If a graph G has 9 vertices, graph G has 9 vertices. So the total number of vertices in the graph 9. Okay. All but one of odd degree. It means that except one remaining all are odd degree. Means how many vertices of odd degree? 8 vertices of odd degree. Please understand this statement. All but one of odd degree. So all but one of odd degree is nothing much. Out of 9 vertices, 8 vertices are having odd degree. One vertex is having even degree. Okay. So therefore we can write here number of vertices of odd degree is equals to 8. 8 vertices are there. Okay. Then the number of vertices with odd degree in G bar. Okay. Remember the basic principle is number of vertices of odd degree in G. The number of vertices of odd degree in G always is equals to number of vertices of odd degree in G bar. Okay. In G bar. Therefore, the answer to this question is number of vertices of odd degree in G is equal to number of vertices of odd degree in G bar. Therefore, in G, how many vertices are there? Odd degree? H. Therefore, answer to this question is H. Number of vertices of odd degree in G is same as number of vertices of odd degree in G bar. If you want, you can verify. You know how to find complement of G, right? In the previous video, we already covered that point. Okay. Therefore, answer to this question is H. 8 is the correct answer. Okay. Next question. If G is a simple graph with 11 vertices and degree of each vertex is at most 5, then the maximum number of edges possible in the graph. Okay. And then what is the principle we can use to solve this problem? Suppose if G is a graph, if G is a graph such that each vertex is having G is a simple graph with 11 vertices and degree of each vertex. Okay. So such that degree of each vertex is at most k. Degree of each vertex is at most k. Then it must satisfy the condition that k into number of vertices must be greater than or equals to 2 times of number of edges. So this point also we covered in the previous video. Okay. So k into number of vertices must be greater than or equal to 2 times of edges. Okay. Here they mention that degree of each vertex is 5. Please observe this one. Degree of each vertex. What is the degree of each vertex? The degree of each vertex is 5. At most 5. The degree of each vertex is at most 5. Therefore, in the place of k, we can write it as 5. At most 5. Into number of vertices. How many vertices they mentioned? 11 vertices are there. 11 vertices. Therefore, number of vertices means 11 Okay. Therefore, this value equals to 11. Greater than or equals to 2 times of number of edges. 2 times the number of edges. Which implies that we can write number of edges must be less than or equals to 55 by 2. 55 by 2. Which equal number of edges must be less than or equal to. What about 55 by 2? So 27.5. Right? 27.5. But what did the ask question? The maximum number of edges possible. Now, what is the maximum value of E which is satisfied this condition? Obviously, the max value of E which satisfies the condition is max value of E, cardinality of E, must be 27. Because number of edges cannot be fractional values. We have to take only integers. Therefore, max number of edges possible, that is 27. Okay. So therefore, answer to this question is 27. Clear? What is the basic principle here? The basic principle is if degree of every vertex at most k, in such case, we can use this principle. Right? So we'll discuss more number of examples in the next video. Okay. Thanks for watching this video.